Hello everybody. In this video, we are going to solve another problem live from LeetCode's top interview 150 problem list. So far, we have solved all the problems up to uh, integer to Roman, actually length of last word. And yeah, if you haven't checked out my videos on those problems, please go to my channel and check them out. The next one is longest common prefix. Okay, let's read the problem and make sure we understand. Write a function to find the longest common prefix string among an array of strings. I see. So it's not just a longest prefix among two strings, it's among an array of strings. There's no common prefix, return an empty string. Okay. Straightforward. Example one is where it's flower, flow, and flight. Yeah, FL is the one where it stops after FL. It's all different, even though these two have an O. This one doesn't. And then the second example has no common characters or at the beginning, so that's an empty string. Okay, makes sense. Let's look at the constraints. The length of the strings array is between 1 and 200 inclusive. So and then each string is also between 0 and 200 inclusive. Okay, and it only consists of lowercase English characters. Yeah, I mean that constraint is not really much useful to us. I guess they've given it to simplify the part where we compare characters in different strings, and basically a literal match of whether characters are the same or not should work. Okay, so I mean the algorithm is pretty simple, right? There isn't much time we need to spend on the algorithm. Basically, we look at the first character in all the strings and make sure and look at whether that is the same. If it is, then we have a prefix of common prefix of at least length 1. Then we look at the next one and so on, and we stop at the first character which does not match, or if one of the strings runs out of characters, right? So that's another thing, and that is all, right? And that would give us our prefix. So I think that would be it. Now, even though the algorithm is pretty obvious, there are a couple of things we should actually work out before we jump into code, right? And some problems like this, it is tempting to jump into code directly as soon as we figure out the algorithm. But I think a couple of things in this case are actually interesting to me. So I would at least figure them out before I jump into code. Okay, so the first thing is, okay, what is how would the code generally look like to figure out if the characters are the same at a specific index in all the strings, right? And I mean, one approach that is straightforward and would work is we will take the character at that index from the first string, and they have even given a constraint, right, that there is at least one string. And we will then look at every other string and make sure that they have exactly that same character, right? And all this while we have to do the bounds check, right? Even from the first string, when we pick the character at a specific index, we need to make sure it is a long enough string to have a character at that index, and same with every other string. So that's one thing. And what is the other thing? I think one other thing to figure out anytime we are incrementally building a string as a result of any algorithm or any code in Java is, of course, we want to use string builder, right? But I think in this case, there is even slightly better way of doing it, and we don't even need a string builder. And the reason is because we basically have a bunch of strings which have that prefix, right? So we can just read it that many characters off of one of the strings, basically the first string, right? And so we don't even need to incrementally build a string, a prefix string, and we can just increment some length of the prefix kind of a variable as long as the characters match, and then at the end we can actually read it right, substring right of the first string. Okay, so I think with that I'm actually pretty ready to uh, jump into code. So okay, so let's say int len equal to 0, right? That's our length of the prefix string. And what else? We just want to, okay, so we basically say, okay, so here I'm going to write something which we will replace later, but while chars at len, actually let's call this index because that is the index we are going to check. Chars at index match in all strings. Okay, what are we doing? We are saying while that happens, we'll just do plus index, right? There is nothing else to do because like I said, we don't need to incrementally build a prefix string. We can read it off of the first string, right? So here, in fact, we say return strs of 0, and they have given to us that there will at least be one string in the strs array, so we can access 0 safely. Dot substring, I believe in, okay, so index would have stopped. So we need to figure out where index would have stopped, right? If the common prefix in this case is of length 2, then index variable would have stopped at value 2 because it would be 0. Then it will increment once when it sees f, then it will increment twice when it sees L, and at that point the characters won't match, so it won't really increment it, right? So which means that we can do 0 comma index, and the reason is because I think in Java the start index of a substring function is inclusive but the end index is exclusive, and this is a very common practice in a lot of programming language libraries which handle strings and arrays. You know, the start index is inclusive, the end index is exclusive, so that should work basically. Yeah, I was trying to figure out whether we need index or index minus 1 there, right? So okay, so with that, now we need to kind of write a helper that does this for us, right? And then we are pretty much done. So we say private, well, it returns a boolean, and let's say do chars match, right? And in Java or many other programming languages, if a thing returns a boolean, if a function returns a boolean, it's a good practice to name it with a prefix like do or is or can and stuff like that, right? Okay, and what is it doing? It's saying, hey, give me the strings array and give me the index which I should be checking whether chars at that index match, right? Okay, so the first thing we need to check is we need to make sure that the 0th string even actually, yeah, has that many characters, right? So actually index, sorry about that. Yeah, so index is less than, if index is greater or equal to that, then we basically say false, right? Return false, because every string needs to have a character at that index for us to return true, right? So even if the 0th string doesn't, then we return false. Otherwise we say char ch equal to strs of 0 dot char at index, right? And then we just write the loop I equal to 1, we start at 1, strs dot length, sorry, I is less than strs dot length plus plus I, right? Okay, and here we again, let's just, oh, we need to do the bounds check again, right? So we say if strs of I, yeah, let me do this. Actually, what I was thinking is, should I take it in a separate variable equal to strs of I, right? Okay, so if str dot index, again, if index is greater or equal to str dot length, then we return false, right? But there is one more condition, we return false, but let me write this. And other condition is, okay, it does not have a character, or it has a character but it doesn't match, right? So str dot char at I, sorry, index, here is index, right? Equal not equal the character at that index in string, in the 0th string, then we return false, right? And otherwise if everything matched, then we return true here. Okay, I think that should work, so let's just call that here, do chars match strs and index, right? Yeah, let's just run through this very quickly manually. Flower, flow, and flight. So there are 3. So strs is 3. We pass that, we pass index 0, right? And we say, hey, do the characters at 0 match. We say, okay, it is within bounds, yes. So index is 0. It is not greater or equal to length of the 0th string. So that's good. We take the character at that f. So ch is f. And we are looking for f in all other strings, right? So we look at the string at index 1, which is flow, and that's here in str, and we say, hey, is the length, does it have enough length? Yes, it does. And then does its character match ch. It does, so we don't return false. We go to the next iteration of the loop and it will check the flight one, and that should work. Okay, maybe a compiler error or two, but otherwise it's very straightforward. Okay, strings. Okay. Let's do this. Okay, cool. So it did accept it. And yeah, we could add a couple of more test cases. Let's see. For example, I think one thing I was thinking about is if we have an off by one error. Well, here already F, L, and then O matches in first two, but doesn't match in last. So that's a good case. But let's say that it's the other way around, right? Where it doesn't. Here it's, well, I'm going to do this because it bothers me that fever is not a word. Okay, and so we could run that as well just to check off by one errors, like, hey, first is special, last is special, and stuff like that. Okay, so that's good. And the other thing we can do is we can submit, which will run a bunch of test cases and also give us our performance. Oh, cool. So runtime, it beat 100% of the submissions. Well, I think in such cases, a lot of the submissions will basically be very simple like this. So that is probably some luck as well in that. And memory is 97.62%. And same thing there. I think when we are using very little memory like this, of one extra memory, it's like very noisy, these numbers, memory numbers. So I wouldn't trust that too much. Okay, hopefully that was easy enough. If you're liking what I'm doing on this channel, please consider subscribing to my channel and please hit that thumbs up button on the video. See you guys next time.